The length of barramundi is approximately normally distributed with a mean of 650 mm and a standard deviation of 100 mm. For game fishing, a barramundi must be between 550 mm and 800 mm long to be considered of legal size. What is the probability that a randomly caught barramundi is of legal size? So what we can say straight away is that x is normal and 650 is the length and 100 is the standard deviation. In this first part of the question, we're after the probability that x is between 550 and 800. So that's just calculator work. Let's just clear everything we've got at the moment. So we're going to go for a distribution, and it's a continuous distribution, and we're going to want normal CDF, and we're going to have 550 up to 800. Standard deviation was 100. And the mean was 650, and that gives us 0.7745. A fisherman catches 100 barramundi in a week. What's the expected number of legal sized fish in the catch? So that's just going to be 100 times the probability, which is 77.45, so we'd say 77 because we must give a whole number of fish. What is the probability that a legal sized barramundi is over 750 millimeters in length? So we're after the probability that x is more than 750 given that x is between 550 and 800. So that's going to be the probability that x is between 750 and 800, because it has to be in the range 750 to 800, divided by the 0.7745 that we had from before, which is this probability. So what we could do here is, let's just copy that, and we'll just paste it there, and then we'll just go down and edit. We want this one actually to be 750 now, so make it 750. That gives us that, and then what we want is that one divided by this one, and that gives me 0.1186. We now want to calculate the interquartile range of the barramundi population. So what we're looking for here is basically the middle 50%. So let's just clear what we've got so far to make clearer what we're doing. So I'm going to go for distribution. This time I'm going for inverse normal. And I'm going to put the tail setting to center and the probability of 0.5 because I want the middle 50%. I know that's 100. And the mean was 650. And that gives me 582.55. So 582.55. This is 650. So the distance here is going to be 650, take away the last answer, so 67.44 and so on. And then we need to times that by 2 to get the whole range there. So we're just going to multiply that by 2, and that will give me 134.9 millimeters. A fisheries researcher suspects that the length of the barramundi population may have changed over time. She intends to investigate this by taking random samples of barramundi and calculating the mean length. Assume that the standard deviation of the fish population is still 100 millimeters. Her first sample of 50 has a mean length of 668, and note we're taking samples of 50 and we're taking the mean. Use this to calculate a 90% confidence interval for the mean length of the population and explain whether this provides strong evidence that the population mean had changed from 650. Now there's 4 marks here, so we can't just bung it all in the calculator. So we're going to have 668. Now let's just think about this. It's going to be x bar plus k sigma over root n. So plus or minus that is going to give us our confidence interval. So plus or minus, now for 90% confidence interval, the k value is 1.645, and of course you can find that from the calculator if you need to. You can go for, once again, an inverse distribution, inverse norm, and if you've got a 90% confidence interval, you're going to have the probability down the left is going to be 5%, so that's 0.05 as a probability, and just use the 1 and 0, and there's your 1.645. It's handy to just know those standard sort of values though. So that's 1.645 times the sigma value, which we know was 100, and we're told it still is, just here, over root 50, because that's the sample size. Now once we've got that down, we can just go to the calculator. So we can now go to the calculator. So we're calculating an interval, and we want variable, and go next. Now the sea level, if you can't remember whether that should be a probability or a percentage, the little help button here will help. It has to be a probability, so for 90% it's 0.9. Now our sigma is 100. The mean was 668, and our sample size was 50, and that gives us 644.7 up to 691.3. Now, the original 650 is within this, so it doesn't provide strong evidence that the population has changed. So 650 is within confidence interval, so no indication of change. With her second sample, she wants to obtain a 95% confidence interval for the mean length of the barramundi population, which has a width of no more than 20 millimeters. So if her mean is here, and the width is 20, that means 10 up and 10 down. Now the K value for 95% is 1.96. Once again, you can find that on the calculator. Times sigma, which we know is still 100, but we don't know the sample size here, so that's root n. And that would give us the width. Remember, we do plus or minus that calculation. And here, that's got to be 10. So, what do we get? So take the root n up here and bring the 10 under. So root n is going to be 1.96 times 100 divided by 10. So we'll calculate that. Let's go back to main. So we've got 1.96 multiplied by 100, and we'll divide that by 10, and that gives us 19.6, and of course that's root n, so we need to square that value. So that would give us 384.16. So that's for n, but of course n has to be a whole number, so we'll go up to the next one, 385.